Hey Emerson, I was thinking about the improper integrals that you sent me yesterday and wanted to provide you some insight into how I think that your teacher wants you to work these. So for the first one, which was the integral from 0 to infinity of x to the 13th over x to the 5th plus x cubed plus 1 cubed, what I would do first of all is I'm going to try to, obviously you cannot integrate this directly. It's not an easy one to integrate. So what you're going to try to do is you're going to try to bound it. You're going to try to bound it either by something below that diverges or by something above that converges. My inclination is that this is going to be convergent. So I'm going to break it up first of all. I'm going to say that this is equal to the integral from 0 to 1 of x to the 13th over x to the 5th plus x cubed plus 1 cubed dx plus the integral from 1 to infinity of x to the 13th over x to the 5th plus x cubed plus 1 cubed dx. There might be a different way, but I think this is when I see things, I always like to sort of when x is, because when x is between 0 and 1, if you make the number bigger, like x to the 14th would be less than x to the 13th. So there's a difference of values between 0 and 1 and things that are greater than 1. So what I'm going to do is I'm going to look at each piece. I'm going to say, what do I know about the first piece? All right. So the first piece, I know that that this value, this integral, so I'm just going to bound it. The integral from 0 to 1 of x to the 13th over x to the 5th plus x cubed plus 1 cubed, I know is dx, I know is less than or equal to 1 over x to the 5th plus x cubed plus 1 cubed. All right, and that's dx, because x is always less than 1. But now x is always greater than 0, so I know that this is less than or equal to, again, x is positive, so if I make the denominator smaller, I make the fraction larger, I know that this is less than or equal to, this is 0 to 1, the integral from 0 to 1 of 1 over essentially 0 cubed plus 0, or 0 to the 5th plus 0 cubed plus 1 dx. Because x is positive, I made the denominator smaller, make the fraction larger, but that equals the integral from 0 to 1 of just dx. And that equals x evaluated from 0 to 1, which equals 1. So I know this first part of that expression is less than 1, which means it converges. The first part converges. All right. For the second piece, I'm going to look at the integral from 1 to infinity of x to the 13th over x to the 5th plus x cubed plus 1 dx, and use this sort of the same idea. I'm going to try to bound it. This is cubed, sorry. So, and this was cubed, but it's still 1 cubed is 1. Now, what I'm going to do is I'm really going to focus on the bottom. I'm going to make that bottom smaller, which makes the fraction larger. So that's less than or equal to the integral from 1 to infinity of x to the 13th over x to the 5th plus 1, okay, cubed. So I dropped my x cubed, made the denominator smaller, make the fraction larger. Oh, but I can do that again. I can drop the 1. So that's less than or equal to the integral from 1 to infinity of x to the 13th over x to the 5th cubed, which is x to the 15th dx. Again, I dropped the 1, I made the denominator smaller, made the fraction larger, so it's bounded. And that equals the integral of 1 over x squared, which is x to the minus 2 from 1 to infinity dx. So that is an upper bound, and now we'll see what that equals. Integrate that. That's going to be add 1 to your exponent, divide by the new exponent. So that's going to be x to the minus 1 over minus 1, evaluated from 1 to infinity. And that equals, let me go over here, I kind of ran out of room. That equals negative 1 over x, evaluated from 1 to infinity, which equals, put in infinity, that's going to be negative 1 over infinity, which equals 0, minus negative 1 over 1, which is equal to 1. So what does that mean? It means this second piece is also less than or equal to 1. So this also converges. So when I do that, I've got two pieces. The first piece converges, so this converges, this converges. These two things equal what I'm trying to say something about. So I think this was integral 1. Integral 1 converges. All right, it's good stuff. Let me know if you have any questions, and I will hope you enjoy this video, and I'll talk to you soon. Bye-bye.